Rule 5. You will hear lots of people say that carbon isotope ratio measures water use efficiency. Mistake, wrong, call them on this. Carbon isotope ratio does not measure water use efficiency. Carbon isotope ratio measures intrinsic water use efficiency. And these are two different terms. So here are some equations to help us understand. These equations are written in terms of Ohm's law analogies. And the first one describes photosynthesis, or assimilation A. It depends on a voltage, which is the Ci to Ca gradient, times a conductance, or the inverse of resistance, G. And I divide that by 1.6 because this is the G value for water. And to convert that G value from water to CO2, I need to divide it by 1.6. Can Chris tell me what the value of 1.6 means?
The diffusion constant.
And why is it 1.6?
Because CO2 diffuses, I don't know, I forget exactly, but diffuses, it describes the difference between the diffusion rate of CO2 in liquid and vapor.
Not quite. I've given you guys the answer earlier. Does anyone remember what I'd said? Will.
The difference in the diffusion rate of water versus CO2 is
Right, but why is it 1.6?
because water is 1.6 times faster.
But why?
It's smaller than that.
To go back and be technically correct, it is the same explanation for why 13 CO2 diffuses faster than 12 CO2. Take the square root of the molecular weights and, oh my goodness, it's 1.6. Okay? So transpiration then, in terms of this analogy, or E, is going to depend on the humidity gradient, which is nu, times G, the conductance. So if I now want to calculate water use efficiency, it's not really an efficiency, but the term that came up over 100 years ago was the ratio of photosynthesis to transpiration, or A over E. When you look at that term, you will see, aha, I've got the CICA values in there, so I can use that to measure water use efficiency. But, oh, doggone it, I've still got that 1.6 nu in there. So you can't use this as directly analogous to water use efficiency because you've got no measure in there of what the humidity is. So instead, if you want to use this term to describe some aspect of what people might call efficiency or regulation of water use, we ask that you use the term intrinsic water use efficiency, which is defined as A divided by G. And if you take the term A divided by G, you see that there's a CICA in there, and that gets you your direct tie to carbon isotope ratio. So just be careful if you want to say that this is a water use efficiency. Now, Roxy is going to tell me, well, it's okay, Jim. I'm growing plants in the same environment. And then I'm going to turn to Roxy and say, now can you tell me that those plants had identical humidity environments and they had identical leaf temperatures? Because if not, then the 1.6 nu is not being held constant. So it's safest just to use the term intrinsic water use efficiency.